As far as the owner of this channel is concerned, Marvel nerds can go and cry. Why? Because Archimedes is what Stan Lee wished Iron Man could be. How? Well, let us explain. The mark left by Archimedes went far beyond leaping from his bath, shouting "Eureka!" and running through the streets naked. At the heart of his many contributions is the principle of displacement, a discovery that's as much about Archimedes' ingenuity as it is about the fundamental forces that govern our universe. This principle, succinctly put, states that any object wholly or partially immersed in a fluid will displace a quantity of water equal to the volume submerged. This was discovered in the aforementioned famous incident in which he discovered the concept while having a bath, noting how entering the tub would cause the water to overflow. It's a concept that seems simple on paper, but has profound implications across a myriad of fields. Take the maritime industry, for example, where this principle is the cornerstone of naval architecture. In this regard, he was laying down principles of physics that would underpin centuries of scientific advancement. Without Archimedes' insights, the design of ships and submarines that grace our oceans today would be fundamentally different. Engineers continually apply this principle to ensure these vessels remain afloat, balancing their mass with the volume of water they displace. But Archimedes' principle doesn't stop at the water's edge. Its applications ripple out into areas as diverse as aerospace engineering and hydrodynamics. In the quest to conquer space, scientists and engineers have leveraged this principle to understand how objects behave in fluid environments vastly different from those on Earth. This understanding is crucial in designing systems for spacecraft that can effectively maneuver through the various fluid mediums they encounter, be it the thin atmospheres of other planets or the vacuum of space itself. Moreover, in the realm of hydraulic systems, which are pivotal in modern machinery, Archimedes' principle is instrumental. These systems, which operate based on the transmission of force through liquids, rely on the foundational understanding of how fluids exert pressure and how objects interact within these fluids. In sum, Archimedes didn't just discover a principle, he unveiled a window into understanding the natural world that has propelled human innovation across the centuries. In the seething cauldron of ancient warfare, specifically during the legendary siege of Syracuse around 214–212 BCE, brute strength clashed with cunning intellect. The claw of Archimedes stood out here, showcasing how brainpower could decisively turn battles upside down, literally. This period was marked by the Roman Republic's aggressive campaigns to expand its influence, encountering fierce resistance from the defenses of Syracuse, a city renowned for its cultural and scientific achievements. The claw, essentially a giant grappling hook operated by a crane mechanism, wasn't just a tool, it was a cunning weapon used to pluck enemy ships out of the water and tip them over. By harnessing the principles of leverage and pulley systems, this device could reach out to the Roman ships, clasp them as if in the grip of a titan, and then, with a force that mocked the very waves they floated on, lift them into the air. The moment of disbelief, perhaps shared by both the besieged and the besiegers, swiftly turned into horror for the Romans as the ships were either capsized or smashed with ruinous force back into the water. This wasn't merely defense, it was psychological warfare. A clear message that Syracuse wasn't going to fall easily, not with Archimedes creating ever more eccentric designs. Another legend is that of Archimedes' heat ray, a device allegedly capable of setting enemy ships on fire using concentrated sunlight, has fascinated historians and scientists alike. The legend of Archimedes using a heat ray during the siege of Syracuse, part of the Second Punic Wars, is another tale of his innovation during and before this siege. According to historical accounts, Archimedes mounted mirrors on the walls of Syracuse, directing the sun's rays towards the invading Roman galleys with such intensity that it allegedly set them ablaze. The effectiveness of this heat ray has been a subject of debate and experimentation, with contemporary tests yielding mixed results. Some experiments, like the one conducted by students from MIT, showed that under specific conditions, clear skies, a stationary target, and concentrated sunlight for an extended period, a wooden ship could catch fire. The TV show Mythbusters explored the feasibility of the heat ray, conducting experiments that resulted in some charring and a small amount of flame on a wooden fishing boat target. However, they concluded the device was impractical as a weapon due to the ideal conditions required for combustion to occur. Similarly, in 2005, MIT students attempted to recreate the heat ray using 127 one-foot square mirror tiles focused on a mock-up wooden ship. Flames did break out on the ship, but only after it had remained stationary under a cloudless sky for around 10 minutes, suggesting that under very specific conditions, the heat ray could be considered a feasible weapon. It should be noted that Archimedes did not only devise death machines, he had a knack for more humanitarian inventions as well. Quite the surprise, right? The Archimedes screw, a brainchild of the 3rd century BC, showcases this perfectly. This device, with its helical screw nestled within a cylinder, was designed to elevate water from lower to higher ground with a simple rotation. This invention's elegance is in its simplicity, yet it heralded a new era in irrigation and water management, transforming agricultural practices far beyond the ancient fields of Syracuse. Fast forward to today, and the Archimedes screw's utility has only expanded, seamlessly integrating into modern industrial processes, wastewater treatment facilities, and even in the generation of eco-friendly hydroelectric power. Its capability to move vast volumes of water efficiently with minimal energy has cemented its status as a cornerstone in contemporary water resource management strategies. It has even formed part of the conceptual basis of the modern-day propeller, used in both aquatic and aerial applications. In areas grappling with drought and water scarcity, the Archimedes screw offers a sustainable solution, echoing Archimedes' ingenuity across millennia. The final invention on our list, the Syracusia, stands as a monumental achievement in the realm of ancient maritime engineering. Crafted by the ingenious mind of Archimedes and constructed by Archias of Corinth upon the orders of Hieron II of Syracuse, this ship embarked on a historic journey from Syracuse to Alexandria. Given as a prestigious gift to Ptolemy III Euergetes, the Syracusia's voyage into history was marked by its unparalleled scale and sophistication. Spanning an impressive 55 meters in length, 14 meters across, and rising 13 meters above the waterline, the Syracusia could accommodate an estimated 1,600 to 1,800 tons of cargo and 1,942 passengers, alongside more than 200 soldiers. Its construction blended unparalleled luxury with the practicalities required for extensive maritime expeditions, reflecting Archimedes' extraordinary ability to innovate across diverse fields. This ship was not just a means of transport, it was a floating palace that showcased the pinnacle of ancient naval architecture and vast wealth of King Hiero, who commissioned the ship. Beyond its immediate impact on ancient seafaring, the Syracusia symbolizes the breadth of human creativity and engineering prowess. It underscores how Archimedes' work transcended the theoretical to make tangible contributions to the world, influencing the course of maritime engineering and trade in profound ways. From designing new methods of sustaining life and other methods of taking it, Archimedes has left a permanent mark on the fields on engineering and mathematics. His death, however, should remind us that even the greatest minds can fall to the simplest of measures. This death would come at the hands of a man very different to him. As Syracuse fell in the later half of 212 BC, Archimedes continued his studies secluded in his home. The Roman commander, Marcus Claudius Marcellus, had ordered the capture of Archimedes, presumably to put his talents in service of the Roman Republic. This was not to be, however. He would be killed where he worked by a Roman legionary at the age of 78. "Do not disturb my circles," were reported to be his final words.